All right, so today we're in section 5.1, solving systems of linear equations by graphing. So like I said, we're actually going to do 3 different methods of solving linear systems, and the first one today is graphing, what we're doing with the graphs. So your terms, there's 2 terms you need to know. What is a system? It's 2 or more linear equations with the same variable. And the solution is an ordered pair that can make the equations true, in the system true. So that's what we're looking for. All right, so here in example 1, where did you plot your first point?
5.
Okay, yes, 5 on the x-axis, very good. And where do I go from there? So I'm looking specifically at the first equation here, y equals 2x plus 5. It's ready to graph because y is by itself, and you just said that your first point goes on the 5. And where do we go from that point?
Up to right 1.
Yes, very good. I go up 2 over 1. So 5 up 2 over 1. And draw that line as straight as you can through the points. Because once I graph the second equation, I need to see where the lines are going to intersect. Okay, where are they going to cross? So I need to make sure that line is as straight as possible. All right, so now let's look at the second equation. Y equals negative 4x minus 1. Where is my first point going to go?
Negative 4.
No. Where does my first point go?
Negative 1.
Negative 1. And where do I go from there?
Go down 4.
To the left 1.
Not left, but
Right 1.
right 1. Because remember, we always run forward. We always go forward. All right, now when you draw your line, okay, so far nothing is crossing, all right? I need to draw my line through this second set of points, and I need to draw it long enough so I can see where the lines are going to intersect, all right? And the ordered pair that represents that point is the solution. So you see, guys, if you don't draw straight lines through these points, you are not going to land on the ordered pair that is the solution, all right? So that's kind of the challenge with graphing to show the solution. Your lines have got to be really, really straight, okay? And you can see, even as straight as my lines are, it's obvious what the x value is, all right? So where they cross lines up with what x value? Negative 1. Do you see that? I kind of drew the arrow up to that intersecting point. It lines up with an x value of negative 1. But my y value is a little harder to determine. But I'm going to say it's closer to the 3. And again, that's just because of the imperfections of graphing. All right. Now, if you said 2, that's pretty close. All right. What now? Where did I get negative 1 from? Can anybody tell me, Elizabeth?
It's where your lines meet on the x-axis.
Yes, very good. So where the lines cross on the x-axis, right here, it lines up with an x value of negative 1. So if they crossed over here...
I'm looking at the Y, I'm like, that is...
No. If they were to cross over here on like an x value of 4 and it lines up with 4, then my first number would be 4. Okay? Now, what is the y value where they intersect? Well, I would say it's closer to 3. It's pretty much right on the 3. Maybe yours is even closer. It can't be 2.5. Okay? So what you can do if you are unsure, especially with the graphing, you're like, man, I think it's the 3, but I'm not sure. There's a way that you can test your solution. Okay? And that's by taking this ordered pair. And again, that's what we're doing. We're saying that this ordered pair, if I plug it into the system for x and y, that both sides are going to equal. So let's test it. All right? I'm saying that 3 is my y value, so plug it in for 3 in the first equation. Equals 2 times negative 1 plus 5. Do you see what I just did there? The point, the ordered pair where they cross, should be the ordered pair that makes these equations true. All right, so is it true? What's 2 times negative 1? What's negative 2 plus 5? 3 equals 3. So I'm good on the first one. That doesn't mean the second one's going to be true, though. Okay, so now let's take the same ordered pair, and this is what's really cool. It's a totally different equation, would you agree? It's a totally different equation, but when I plug in that ordered pair, it should still be true. All right, let's try it. 3 equals -4 times -1 minus 1. What's -4 times -1? +4 minus 1 is 3. All right, so this ordered pair, this is not my answer. This is just me checking it, and your homework is not even going to ask you to check it, okay? Your answer is in red. All right, that's your answer. And you showed that on your graph. All right, so you only have 6 problems on your homework tonight, but it's quite a bit of graphing. All right, so the first one's not a graph. But it's, you know, that's another reason why I didn't give you too many problems to work. All right, example 2. Example 2 is the same thing I just did in example 1 with one exception. Write these equations down and see if you notice something that might be different about these equations. I'm still doing the exact same thing I did in example 1. Just one thing is different. Okay, what do you notice? Yes, very good. So the first equation, is the first equation ready to graph? Yes, but is the second equation ready to graph? No. So as you're writing it down, that's what you need to be focused on, is how do I get my second equation ready to graph? And what do I mean by ready to graph? Y by itself, slope-intercept form. Okay, what would I do first to both sides? And this is something that we've already learned, right? So our brain should be firing right now because we know how to do this, right? We've already learned this. What do we do, Lily?
You subtract x.
Close. It's already subtract, so I need to...
add.
Yes, very good. I need to add x to both sides. 2y equals, which term do I write first? -4 or x? All right, so I still have some people switching that up, so make sure the x comes first. -4. Is it ready to graph now?
No, you have to divide by 2.
Divide everything by 2, but this, yes, I like the way you're thinking. You're one step ahead of me. That's good. This x by itself can get confusing, so I would suggest that you put an understood 1 there. Now divide everything by 2, and you can clearly see it's 1/2 x minus 2. All right, so I'm going to kind of cut you loose now. I want you to graph both of these equations, draw your lines, and try to find the ordered pair where it intersects. That ordered pair is your solution. Okay, so the first point, let's just kind of get going on it. -2, where do I go from there?
Where's the left?
Where do I go from -2? Up 2 over 1. Okay, very good. Up 2 over 1. And draw your line. Did you get it like super straight? Okay. Now, on this second equation, where does your first point go? At -2 again. So I just kind of like circle it, like this is the second point, or you can make it a little bigger, or you could just leave it. But you know that the point's already there, and it's also the first point for your second equation. I love it when this happens. Okay, where does your second point go from that equation? Up 1 over 2. You still have to draw that line. But now, what's different with this one is the lines actually intersect on one of the points. That's really nice when that happens, because there's no doubt what the ordered pair is that is a solution. Write it down on your papers if you haven't already. At what ordered pair do these lines intersect? All right, get that written down. Okay, and what is it?
0, -2.
0, -2. Now, is there a way that I could check that? Is there a way I can check that? What does that mean? What does it mean? Okay, it means that this value would make both equations true if I were to plug it back in, plug these values in. So you don't have to write this part just because of time. We're almost out of time. But I want to show you. What now?
How did it intersect again?
It intersects at 0, -2, because it doesn't go either way on x, and it just goes down to a -2.
Oh.
That's where they cross. Okay? So now I'm going to check it. I'm like 99.9% sure this is the ordered pair that's the solution. Now I'm going to plug it back in to make sure. Plug in -2 for y and 0 for x. -2 equals 2 times 0 minus 2. Well, what's 2 times 0? 0. Minus 2? -2. So it's true. Yay, that's great. But I need to check the second one. So let's come down here. -2 equals 1/2 times 0 minus 2. Well, what's 1/2 times 0?
0.
Minus 2? All right, so it is a solution. Again, is this part, the checking part, mandatory? You have to do it. No. What you do have to have, and it's really sad when you have the graph and then you forget to write the ordered pair. The ordered pair is your answer. This is how, the graph is how you found your answer. Are you with me? Okay, so one more example, example 3. Okay, I want you to read this problem to just read the first paragraph to yourself. Go ahead and read the first paragraph to yourself, and then we're going to kind of break it down. Okay, what is this problem about? What's the topic? Plants. Okay, so we're in trouble. We're in trouble if we can't at least get to that point. Everybody know the topic is plants. Okay. What else? What else?
Experiment.
There's an experiment with how many plants? 2. So again, we're in trouble if we can't read the problem and kind of pick out of that problem that there are 2 plants. So, what have we been doing this whole lesson? 2 equations. So, each plant is going to have an equation. Put your hand down for a sec. I'll get your question in a sec. Okay? So, this is, we're going to set it up using slope-intercept, y equals. And now I need a value. All right, y equals, what is that next variable that comes after the y? M? M? M stands for what? Slope, but it stands, in a word problem, it stands for the rate. The rate. Remember how we talked about constant rates? So the M in an equation stands for the rate at which something is changing. So there should be some information in here that is setting some kind of a rate. I need to decide what that number is. Think you know? What would it be? 1, because it's growing 1 centimeter per week. 1x. Okay, I don't know how many weeks. X is the weeks. Okay? And then the last number in my equation is my starting point. My number that's not affected by the rate. Not directly, at least. So what's my starting point for plant A? It's the height is 8. Its height is 8 centimeters. And it's growing 1 centimeter per week. But I don't know how many weeks it's going to grow before it dies. I mean, you could say that. All right. And now you've set up your equation. So you need to understand what the numbers in the equation mean. The number that's connected to x has to be the rate at which some value is changing in your word problem. All right, based on that information, I want you to set up your equation for plant B. Anybody give me the equation?
Can I try?
Anybody give me the equation? Caitlin?
Y equals 2x plus 1.
Okay, do you agree with her?
Yeah.
Okay, so if you learn nothing else, who got that equation right? Who got that equation right? If you learn nothing else in this lesson, I would say, are you listening? It's a huge success that you understand that the number connected to x is your rate of change. Slope means the rate of change. So that's huge. That's awesome. All right, and if we were to graph this, here's what we're trying to determine. Plant A starts off taller than plant B. Would you agree? Based on their heights. But what's true about the rate at which they're growing?
It grows faster.
Plant B grows faster than plant A. So at what point, here's my question, and what I could answer on a graph if I were to graph this. At what point will they be the same height? So if they were growing at the same rate, would they ever be the same height? No. They would be, that's why it's parallel. If the slope is the same, they will never intersect. They will never have a solution. You see that? If they were growing at the same rate, but they're not. Because they're growing at different rates, they will at some point intersect. There will be a solution. Is that coming together a little bit? Okay, and that's everything you need to know for section 5.1.